Okay, so the curve C has this equation here, which I've written down there, where K is a constant. It says then the two stationary points on the graph of C are denoted by Q and R, and the x coordinate of Q is -1. Find dy dx and hence show that K is -3. Okay, well, dy dx in this case will be, well, you bring the 3 down, so it'll be 3x and then squared. Now in this case then you bring the 2 down, okay, bring the 2 down in front. There's a k there, but remember that's just a constant, so it'll be 2 times the constant, so it'll be 2k, x then to the power 1, and then of course minus 9x becomes minus 9, and then minus 10 disappears. So we can use this information here, can't we? Alright, because it says two stationary points, Q and R. And of course, at the stationary points, like a max or min for instance, the gradient is equal to 0, isn't it? Okay, so i.e. 3x squared plus 2kx minus 9 is 0, okay? But given Q is a stationary point, and at Q x is equal to, what's it say, -1, we can then sub it in to here to work out what my k is. So literally subbing it in, so you get then 3 here minus 2k here minus 9 equals 0. Okay, so then minus 2k minus 6 is 0. So then 2k is equal to 6, or rather 2k is equal to minus 6, so then k will equal to minus 3. We've got exactly what they've asked for. Okay, so part B then, it says find the x coordinate of R, right? So of course then there's another stationary point, yeah? Okay, with R. So what I can do is I can go back to this, can't I? So I can say, look, 3x squared plus 2 times minus 3x minus 9 is 0, because I know now k is minus 3. I can sub it back in there, so I get 3x squared minus 6x minus 9 is 0. Okay, and I can factorize that then to find the solutions. Okay, now of course one of the solutions is going to be this, isn't it? It's going to be x minus 1, one of the solutions, but I can get the other solution then for R. Before I factorize, you can see that 3 is a common factor, so I divide by 3. I get that. 2 brackets then, x in both brackets. So the numbers are 3 and 1, of course, and we want this to be minus 3 and that to be positive 1. Okay, so we can say then either x plus 1 is 0 or x minus 3 is 0. So that means x is minus 1 or x is 3. Okay, now of course we know that corresponds to point Q, so that corresponds to point R. Right, so we've got the x coordinate there of R. Now they don't ask us, if you notice, they don't ask us what the y coordinate is, what the overall coordinate, so we don't need to do it. Okay. Part C then says determine the nature of each of the stationary points of Q and R. Now to get their nature, we need to see whether they're a max or a min. So remember now, dy dx is equal to that, isn't it? That's what dy dx is equal to. Dy dx is equal to 3x squared minus 6x minus 9. So d2y by dx squared, the second derivative will be 6x minus 6. So we can just simply plug it in then. So 1x is minus 1. d2y by dx squared will be 6 times minus 1 minus 6, which is minus 12. So that's less than 0. Therefore, we have a maximum. Okay, 1x is minus 1. 1x then is 3. d2y by dx squared will be 6 times 3. Take away 6, which will be 12, greater than 0. Therefore, that will be a minimum.